Right, we've been looking at these graphs, but now let's look at some of the possibilities that we could find. So let's try to make sense of this, because these are the sort of questions you're going to get asked in the test. Now, we've seen that whenever we see a straight line, it tells us that things change the same all the time. Alright? So in this case, we can see that we're starting off, and you should always tell me this, starting off low, going to high. Right? Whether this is distance or speed doesn't matter. But all we can say is it's happening at the same speed, rate, pace, whatever you want to say. So we call it a constant rise. And this is always true for a straight line. Whenever you see a straight line, the word constant should be used in your explanation of what it's actually doing. So if it can go up, then it can also go down. And this time we've got it decreasing at a constant pace, or it's decreasing at the same all the way down. It doesn't change at all. This case it starts high and comes to low. We will see in our looking at graphs in our written lab reports that we have to maybe talk about how changing in this affects changing in this. So in this case we could see that as the distance, or rather as the time increases, the distance decreases, and that would be a good way of telling me about it. But sometimes when we get there and we're looking at graphs, they're not straight lines anymore, and we can get some funny shapes. So in this one we saw the first graph we looked at, it started off low and went to high, but this time, because there's no straight line joining the two endpoints, we know that the increase changes. Now if we look at this, the distance it covers to start off with is not very big. But then as the time increases, the distance increases very quickly. So we can say it starts off slowly and then quickens, and that would be the type of answer I would expect. It can also do the opposite. As we're going to see with curves, there are basically four options we can have. So the other option is, in this case, it jumps very quickly in distances in a short amount of time. So it starts off quickly or fast and then slows down at the end. Now sometimes we might actually see this endpoint here develop into a straight line. A flat line over here, which means something as well. So we actually see these changes. Now let's look at the last two. So if it rises that way, then surely it can fall that way too. So in this case, we see that it starts high and goes low, but it's not a straight line, which means it's not constant. So it must decrease, and well, in this case, the distance changes really, really quickly in a short amount of time and then slows down. If we then go to our final option, it looks like this. And again we see that the distance changes, starts off at far away, or distance is the highest it's going to be. And then it gradually changes back to, in this case, back to 0. But it starts off and the distance doesn't change much in those first bit of time. So it doesn't really start changing a lot until about here. So we can see it starts off slowly changing and then quickly at the end. So those are the sort of things you need to look out for, and they are things you need to tell me very clearly about. So when you're doing this, don't be frightened to write what you see. If you see it changes at a constant, then tell me that. If you see it changes quickly then slowly, or slowly then quickly, tell me that. Also tell me whether it gets bigger, starts off small and gets bigger, or starts off big and gets smaller. They're the sort of things I'm looking at. Don't be frightened to include all of them.